John will be speaking about the DOE Fossil Energy R&D Program. John, whenever you're ready.
So good afternoon, everybody. Thank you for joining in to hear about DOE's Fossil Energy R&D Program. I'm the Associate Director for Strategic Planning at the National Energy Technology Laboratory, or NETL for short. NETL is part of the Department of Energy's Office of Fossil Energy, and we support FE in the implementation of their R&D programs. And today I'll be presenting a very high-level overview of the Fossil Energy R&D Program. It's currently comprised of 450 active R&D projects valued at $2.2 billion, and it spans 27 different program budget lines, so it's pretty expansive. So the Fossil Energy R&D Program is currently being somewhat realigned to align with the priorities defined in the President's America First Energy Plan. And those priorities are advancing clean coal technology, and we're doing that for both existing and future coal plants. Reviving America's coal industry, and we're doing that by developing technologies to utilize coal more cleanly and economically, and also by developing technologies to recover rare earth elements and other minerals from coal and coal byproducts. Another priority is to increase domestic energy production. Some ways we're doing that is by reducing the environmental and safety risks of producing and transporting unconventional and offshore oil and gas resources, by also improving the production efficiency and ultimate recovery of those unconventional resources, and also by looking at how we can develop technologies to produce our vast yet untapped gas hydrate resources. A final priority in the America First Energy Plan is to improve our energy security, and fossil energy is contributing to that, but just by developing technologies to enable us to continue to use our abundant fossil energy resources, and also by making fossil energy conversion plants more reliable. Historically, the Fossil Energy Coal R&D Program has been designed to address 4 big technology challenges associated with using coal. And those are, first and foremost, capturing and storing carbon dioxide emissions from both existing and future coal plants, minimizing the water use of today and tomorrow's coal plants, reducing the capital and operating costs of the advanced technologies we're developing for the next generation of coal plants. And finally, we have had a historical focus, and it's continuing under this administration, on improving the efficiency, environmental performance, and the reliability of our existing coal fleet. Before I present more details of the FE R&D program, I'd like to talk about why I think it's so important. First of all, the world needs affordable, reliable energy. As this slide shows, there's a strong correlation between per capita energy use, which is shown on the horizontal axis, and gross domestic product per capita, or standard of living, which is shown on the vertical axis. And accordingly, across the world, there's a desire to maintain, or for many countries, increase their energy consumption. And for the coming decades, much of that energy will continue to come from fossil fuels. Because of the world's existing and future dependence on fossil fuels, there's been many studies to look at how will we continue to use fossil fuels while reducing greenhouse gas emissions. This study that I'm showing here from the IEA showed that carbon capture and storage, which is one of the main technologies we're developing, is essential for meeting greenhouse gas reduction targets. In their 2016 report, they projected that they're looking at a scenario where greenhouse gas emissions would have to be reduced by 52% by 2050 compared to 2010 to limit global temperature increase to 2 degrees Celsius. In that analysis, they concluded that carbon capture and storage would have to be used to achieve 14% of the reductions. And that's even though they also assumed that overall fossil fuel use would decline by 2/3 compared to business as usual. So they've in their scenario, they assume that much of fossil fuel use goes away, and yet we still need CCS for 14% reductions. Some of that CCS will also be applied to biomass utilization. They also found that if CCS was not a tool that we could use, the cost of complying with greenhouse gas reductions for the power sector would increase by over 40%. So relatively speaking, CCS is one of the cheaper alternatives to reduce greenhouse gas emissions. And they also pointed out that carbon capture and storage is also one of the only tools that can be used for certain industrial sectors, apart from even power generation. This next slide shows that what I've alluded to earlier, under a business as usual, policy neutral scenario, projections show by IEA and the United States Energy Information Administration, they show that world energy consumption is expected to increase by 50% between 2012 and 2040, and the fossil fuel share is projected to remain at 80% or greater, both worldwide and in the United States. It is uncertain what the future holds for energy use. This scenario, will probably not be what emerges, but it is wise to prepare for multiple plausible futures. And if there's a scenario that does approach this one, in which fossil fuels continue to supply maybe not 80%, but still a significant portion of the world's energy, it's really critically important to continue development of technologies that enable fossil energy production and use to become cleaner, safer, and less costly. And that's really what the Fossil Energy R&D program is intent on doing. So this next slide, NETL participates in the Stanford's Energy Modeling Forum, and that forum is assessing ways in which the United States could reduce economy-wide greenhouse gas emissions by 80% between 2015 and 2050. This slide shows NETL's contribution to that effort. We modeled how deep decarbonization would be achieved, assuming minimum system-wide power generation cost for two different scenarios, one without successful carbon capture and storage research, and one in which we meet our targets for our carbon capture and storage research. The bar chart on the left shows that without success in carbon capture and storage, large increases in renewable and nuclear power generation will be needed to meet that deep decarbonization target. The bar on the right shows that if our R&D targets for CCS are achieved, CCS on fossil fuels, CCS on biomass will be the preferred technology for low-cost system-wide power generation, and it will supply the majority of power. And the gray hashed bar here shows the CCS applied to fossil, and about 60% of that is coal-fueled and about 40% is natural gas-fueled. So one of the overarching goals of FE's coal R&D program is to reduce the cost of electricity of coal power plants with carbon capture and storage. And compared to carbon capture and storage technology in 2012, our goal is to reduce the cost of electricity of these plants by 20% by 2020 and 30% by 2030. And one important point is that achieving these goals will not only require improvements in carbon capture technology, but also improvements in the cost and efficiency of the base energy conversion system, the base plant itself. And so we have our program is designed to develop technologies in both spaces. So for fossil energy conversion, the Fossil Energy R&D program is developing advanced technologies for two different pathways. One is coal gasification, that's shown, and those technologies are shown in the upper portion of this chart, and also coal combustion, which is in the lower half of the chart. In general, technologies are also being developed for two timescales. We call second-gen technologies. We're developing those for 2020 on the left-hand side of the chart in the purple, and transformational technologies by 2030, which are shown on the right in the orange. Supporting both pathways and timescales are several of our cross-cutting technologies. These are sensors and controls, water management technologies, We do a lot of research in advanced modeling, simulation-based engineering, and also high-performance materials. And many of the technologies developed in the coal R&D program are also applicable to natural gas conversion, and those are highlighted here in yellow. So, for example, our combustion turbines often are deployed first under natural gas applications, and the same is true for fuel cells. This slide shows the structure of FE's coal R&D program. At the top, our Advanced Energy Systems program is developing advanced technologies for coal combustion and gasification, as well as for advanced turbines and fuel cells that can operate on coal-derived syngas or natural gas. We also have a program called STEP, which is second from the bottom here, that's developing technologies for direct and indirect supercritical CO2 power cycles. And these are cycles where CO2 is the working fluid. Our carbon capture program is developing more efficient and lower cost technologies that can be used to capture CO2 emissions from both existing and future coal plants, or fossil energy plants, or industrial sources of CO2. They're also applicable to biomass fueled systems. Our carbon storage program is developing technologies to ensure safe, effective, long-term storage of CO2 in the subsurface. So after we capture the CO2, we compress it generally to 200 psi and inject it underground, deep underground. This program also looks at carbon storage that is associated with enhanced oil recovery. Our cross-cutting research program is developing the new materials and sensors and controls that will be required for the extreme operating environments that are associated with most of our advanced fossil energy conversion systems. Typically, to make these things more efficient, we're operating at higher pressures and higher temperatures. This requires new materials, new sensors. The cross-cutting program is also developing simulation-based engineering tools, and really the focus here is to help our research be performed more quickly and also with lower risk. Increasingly, we can do things with modeling that can supplant or supplement laboratory experiments, tell us how to design those experiments, what's most important to look at in those experiments, and so that's been a big help to our program. We also, in our cross-cutting program, are developing technologies to minimize water use. And our final core program, which began in 2014 here at the bottom, is our rare earth elements program, and it's looking at trying to determine the economic feasibility of recovering rare earth elements as well as other minerals from coal and coal byproducts. NETL's, or the FE coal program budget in FY17 was $386 million, and about half of that was for carbon capture and carbon storage. There are 390 active projects in FE's coal R&D program. They have a combined value of over $2 billion, which includes DOE funds plus over 25% cost share. Our biggest programs are carbon capture and storage, followed by our advanced energy systems program. This slide shows the structure of FE's oil and gas R&D program. In our unconventional program, we're developing technologies to make production from unconventional oil and gas resources, such as shale gas, more efficient, more effective in terms of ultimate recovery, percent recovery of the gas or oil in place, and also environmentally benign. In our offshore program, we're primarily focused on developing technologies to improve the safety and reduce the risk of spills associated with ultra-deepwater production. Our midstream or natural gas infrastructure program, we're investigating the extent of how much methane is leaking from that transport infrastructure, and also developing technologies to avoid or mitigate those emissions. And finally, our methane hydrates program is characterizing how massive this energy resource is, while also developing technologies to produce it in both an economical and environmentally acceptable manner. The FY17 oil and gas program budget was $64 million, and about half of that was dedicated to our unconventional program. There are 65 active projects in our oil and gas program portfolio. The combined value of those active projects is about $200 million, and that includes about 28% cost share. Hydrate's portfolio has the greatest value, but our unconventional program has the most projects. This is my final slide. I showed this I want to show you the breakdown of our active projects, and this is all of our projects excluding our small business innovative research projects in the whole FE program portfolio. And I've charted them here by their beginning technology readiness level. And this just shows that the greatest number of our projects and also our lowest value projects begin at TRL 2. The number of our projects become fewer and they become more expensive as their technology readiness level increases. FE funds high risk R&D, so many of the technologies end up failing, and our intent is to fail early and fail cheap. And we also want a large number of low TRL projects to increase our chances that an acceptable number of technologies successfully mature to deployment. At the lower TRL levels, this chart shows that in the orange bars are universities, the blue bars are national labs. Those two types of organizations really dominate that lower TRL level R&D. But as the technology matures, our industry stakeholders become a more prevalent and more significant portion of our collaboration base. And that concludes my presentation. You can obtain more information on the FE R&D program at either the NETL or DOE FE website.